Welcome to the F5 Networks Advanced Web Application Firewall Demo and Exercise Series. In this demo, we'll show how to use a BIG-IP Advanced WAF bot defense profile to protect web applications from Layer 7 bot attacks, in addition to using a denial of service protection profile to protect against Layer 7 DoS attacks. This is an exercise, which represents Demo 40 of the AWAF demo series, and it's intended for advanced level BIG-IP Advanced WAF users. For optimal viewing, we recommend using full screen mode. The environment for this demo contains 3 devices. A Windows workstation will be used to submit Layer 7 bot attacks and Layer 7 denial of service attacks against the web application. These requests will arrive at the F5 BIG-IP system, running Advanced WAF. The BIG-IP system sits in front of and protects the backend web application. The BIG-IP system, using its full proxy architecture, examines every request and can block all Layer 7 bot and DoS attacks and prevent them from going to the backend web servers. First, we'll create a basic BIG-IP Advanced WAF security policy for the virtual server. A security policy isn't required to use a bot defense profile or a DoS protection profile. We're creating this security policy so that you can view request details using the BIG-IP Advanced WAF event log. Next, we'll create a custom BIG-IP Advanced WAF logging profile. We'll give the logging profile a name. We'll then select the log application security, DoS protection, and bot defense events. On the Application Security tab, we'll select to log all requests. On the DoS Protection tab, we'll select the local publisher. And on the Bot Defense tab, we'll select Local Publisher, and then select to log all bot defense events. We'll now attach the event log to the virtual server. This is the virtual server we'll be protecting. We'll use the virtual server security policies page. We'll enable logging, then add the custom log profile, and then update the virtual server. We'll now simulate some Layer 7 attacks against the DVWA web application. We'll open this program, which we'll use to submit several attack scripts. The first attack uses Apache Bench. Apache Bench, or AB, is a single-threaded command-line computer program for measuring the performance of web servers. This command quickly sends 100 requests for the login logo.png file to the virtual server at 10.1.10.35 and displays the results in milliseconds. Let's view the BIG-IP Advanced WAF event log. You can see that because of the attack, all 100 requests for the login logo were considered legal by the Advanced WAF security policy and forwarded to the web server. We'll clear the log file of all entries. Next, we'll use the curl command to attack the web application. Curl is a command line tool for getting or sending files using URL syntax. The 1 through 60 code runs the curl command 60 times. The curl command result is the HTML web code for the DVWA login page. Let's refresh the event log. Because of the attack, all 60 requests for the login.php URL were accepted by the BIG-IP Advanced WAF security policy and forwarded to the web server. We'll clear the log entries again. Now, we'll use a script called Phantom.js. Each time DAM vulnerable web app, DBWA-login displays, indicates a successful request for the DBWA login page. Because of the attack, hundreds of requests for the login.php URL were considered legal by BIG-IP Advanced WAF, and forwarded to the web server. If there were thousands of bots in a botnet, sending these same commands, it would likely overwhelm the web servers, and take them offline. Next, we'll use Chrome to access the DBWA login page. We'll then use the Chrome UA spoofer. This tool enables us to spoof and mimic different user agent strings. First, we'll spoof the Mac Safari web browser. Next, we'll spoof the Internet Explorer version 6 web browser. And finally, we'll spoof an Android browser. We'll then reset the tool back to Chrome default. Once again, we'll refresh the event log. And then, we'll use the filter option to only display log entries for the login.php URL. Let's select the first log entry and then examine the user agent header. This request appears to have come from an Android device. The next request from IE version 6. And the next from a Mac running Safari. This request appears to have come from the correct browser, a Chrome web browser. Now, let's protect the web application from these DoS bot attacks. To do this, we'll create a BIG-IP Advanced WAF bot defense profile. We'll give the profile a name. We'll change the enforcement mode to blocking. On the bot mitigation settings page, for untrusted bot, we'll select the CAPTCHA mitigation option. And for malicious bot, we'll also select the CAPTCHA mitigation option. On the browsers page, for browser verification, we'll select Verified Before Access. We'll also change the grace period to 2 seconds. We're lowering this value for the purposes of this demo. However, in a production environment, 300 seconds would be an appropriate amount of time for a legitimate browser to reply to the JavaScript challenge. That's all it takes to create a bot defense profile. The last thing we need to do is add this profile to the virtual server. Once again, we'll use the virtual server security policies page. We'll now simply enable the bot defense profile option, and then select the new bot defense profile. We'll now update the virtual server. Let's open Internet Explorer, and then open the DBWA login page. Let's examine the BIG-IP Advanced WAF bot defense bot requests log. This log displays all BIG-IP Advanced WAF bot defense data. This log entry was generated when the web browser was initially challenged. When we select the login.php log entry and select all details, we can see that this request passed the JavaScript challenge. Therefore, the request was accepted. We'll now open Chrome again and use the Chrome UA spoofer tool to select Mac Safari. and then open the DVWA login page. We're now presented with a CAPTCHA challenge. We'll then enter the correct CAPTCHA challenge. Let's now refresh the bot requests log. We can view the CAPTCHA status, which in this case was the correct answer. This is why the request was alarmed, but accepted. We can also see that BIG-IP Advanced WAF identified this from the malicious bot class, presenting itself as Safari. We'll once again open Chrome and use the Chrome UA spoofer tool to select the Android browser and then open the DVWA login page. This time we'll enter an incorrect CAPTCHA answer. After refreshing the bot requests log, we can see that this last request was challenged. However, the incorrect CAPTCHA challenge was entered. We'll now resubmit the curl command. You can see that the 60 curl commands all fail, because they cannot pass the CAPTCHA challenge. Notice that all the new log entries are challenged, but none of these requests pass the CAPTCHA challenge. BIG-IP Advanced WAF identified these as a curl bot from the untrusted bot class. Let's refresh the event log. There are log entries from the Internet Explorer request. However, because none of the curl requests passed the CAPTCHA challenge, none of these requests were forwarded to the web servers. We've decided to require tighter mitigation for both malicious and untrusted bots. We'll select the bot defense profile and open the bot mitigation settings. For untrusted bot, we'll change the mitigation to block. And for malicious bot, we'll change the mitigation to TCP reset. Let's once again resubmit the curl command. Notice that these curl commands are now being blocked by BIG-IP Advanced WAF. Next, we'll resubmit the Phantom.js script. Notice that the page title isn't displaying. That's because Phantom.js isn't receiving an HTTP response, due to failing the browser challenge. When we refresh the event log, you can see that again, there are no log entries. All new curl and Phantom.js requests were blocked by the BIG-IP Advanced WAF bot defense protection prior to being examined by the BIG-IP Advanced WAF security policy. After refreshing the bot defense log for the newest entry, we can see that the requests for index.php were challenged by BIG-IP Advanced WAF, which the script could not respond to. We'll now run a new Apache bench command, configured to submit 1000 requests for the login logo.png file. You can see that Apache bench fails to submit the 1000 requests to the web server. Once again, there are no new log entries, as all new Apache bench requests were blocked by the BIG-IP Advanced WAF bot defense protection. In the bot defense log, we can see that these requests were denied and issued a TCP reset. We can see that the AB bot signature was detected. We can also see that the bot category is DoS tool, and that this was a malicious bot. In the next part of this demo, we'll enable Layer 7 DoS protection. First, we'll open the Virtual Server Security Policies page, and then disable the bot defense profile. We're doing this so we can first show a successful Layer 7 DoS attack. We'll now use a utility called LOIC, or Low Orbit Ion Cannon. LOIC is an open-source, network stress testing, and denial of service attack application. We'll enter the virtual server IP address as the target. Add the security.php URL as the subsite. Select the HTTP method, and clear the wait for reply checkbox. We'll then start the attack, and let it run for about 5 seconds. In just a few seconds, over 1,000 requests for the security.php URL were considered legal, and sent to the web servers for processing. We'll now create a BIG-IP Advanced WAF DoS protection profile. We'll give the profile a name. On the behavioral and stress-based detection page. For the purposes of this demo, we'll turn this feature off. On the TPS-based detection page, we'll enable this feature, and set it to blocking. Using TPS-based detection, BIG-IP Advanced WAF can block Layer 7 DoS attacks, based on the client side, and based on number of transactions per second. Next, we'll edit the default values for by source IP. We'll enable both client-side integrity defense and request blocking. And then for request blocking, we'll change this to block all. If traffic from a single source IP address meets the conditions we're about to set, BIG-IP Advanced WAF will issue a JavaScript challenge. Advanced WAF will then block all requests from the suspicious IP address, for the period set in the prevention duration section, at the bottom of the page. We'll modify these 3 values. And then in the prevention duration section, we'll modify this value. We're lowering these values, for the purposes of running this demo, in a virtual environment. However, the default settings are appropriate for most production environments. That's all it takes to create a DoS protection profile. We'll now add this profile to the virtual server. We'll enable the DoS protection profile option, and then select the new DoS protection profile. We'll also enable the bot defense profile option, and select the bot defense profile. This profile is used to help trigger the DoS protection profile. We'll now update the virtual server. We'll now open the DoS dashboard report. And we'll enable the real-time option. We're going to use a second workstation for this demo, which uses a different IP address. We'll resubmit the LOIC attack for several seconds, to send a massive number of requests to the DVWA web application. We need to let the attack run long enough for the client-side integrity mitigation to kick in, and then the request blocking mitigation to kick in after that. After the attack, we'll open Internet Explorer and then attempt to open the DVWA login page. We are blocked from accessing the page from this workstation due to the source IP request blocking. Let's try to access the DVWA login page from the second client workstation. The source IP request blocking only affects the client workstation that launched the attacks. All other users, from different workstations, can still access the web application. Let's refresh the event log. Only the requests from the second workstation, using IP address 10.1.10.51, were successful, and were sent to the web servers. All the DoS attacks sent by the Loic tool were blocked by the BIG-IP Advanced WAF DoS protection profile, prior to being examined by the BIG-IP Advanced WAF security policy. When we refresh the bot requests page, the initial requests from Loic were denied, because they were identified as a malicious bot. We'll now use Loic to run another DoS attack, and let it run for several seconds. Let's examine the DoS dashboard. You can see, there is a DoS attack, currently underway. We can place our mouse over an attack, to get more details. When there are several attacks in this window, we can select one, and then examine the details of the attack in the Attacks section. We can also customize this section by removing columns, such as the virtual server, the start time, and the end time. We can now view the duration of the attack, and we can see the current number of blocked requests. On the right side of the page, we'll expand the Mitigations widget. From this, we can see that upon launching the DoS attack, initial requests match the client-side integrity mitigation, based on the JavaScript browser challenge, and then after a certain point, requests started getting blocked, because their source IP address was blocked. Let's now examine the bot defense, bot traffic report. This report displays several bot traffic statistics for the entire BIG-IP Advanced WAF system. If the BIG-IP system has several virtual servers, we can view bot statistics by virtual server, by selecting a specific virtual server in the left panel. In the Traffic by Class section, we can see the amount, and percentage, of requests in the past hour from malicious bots, from web browsers, and from untrusted bots. In addition to requests from suspicious web browsers, mobile applications, and trusted bots. In the Bot Categories section, we can see the amount, and percentage, of requests from bots in different bot categories. In the Denied Requests section, we can see the amount, and percentage, of requests that were denied, because they were blocked, or were issued a TCP reset, or failed a CAPTCHA challenge, or failed a browser verification challenge. At the bottom of the page, we can click View Detected Bots, which displays all bots that have been detected in the past hour, by the BIG-IP Advanced WAF, bot defense, with details about each bot. Finally, we'll open another log file. The DoS, Application Events Log. The first log entry identifies when the L7 DoS attack was identified, and source IP client-side integrity defense began. The second log entry is when the IP address failed the JavaScript challenge, and was considered suspicious, and BIG-IP Advanced WAF began to block all requests from this IP address. The third log entry identifies the end of the DoS attack. We can expand an entry to see more attack details, including the source IP address of the attack, which is the IP address that's being blocked by BIG-IP Advanced WAF. Thank you for watching this exercise on using both an F5 BIG-IP Advanced WAF, bot defense profile, and a DoS protection profile, to protect web applications from both Layer 7 bot attacks and denial of service attacks. We encourage you to watch additional AWAF demos and exercises, and for more details on how Advanced WAF can protect your web applications, contact your F5 Network Sales Account Manager. For questions or comments about this video, contact Chris Manley at the email address at the bottom of the page.